I'm Justin Diaz, and this is the reassessment for kinematics. And I tried to make up a problem, so bear with me if it doesn't make a whole lot of sense as far as number-wise go. But basically, what the drawing shows that you're on top of a mountain, you throw a ball at 70 degrees with respect to the horizontal, and you got to find the distance r and the time it takes to hit the ground. And the first thing I did was wrote down what I knew. I knew that the initial velocity was 20 meters per second. And then I went out and I saw for the x direction of it, and you got delta x of vi of x times t, which is the change in x, equals the initial velocity of x times time. And you just solve it, fill in what you know for it, and I knew that is 20 cosine 70 degrees is the initial velocity, which when you solve it out becomes 6.84. And then you're trying to solve for r, and you have all that in the initial. When it comes out, you end up getting t. Well, actually, you're solving for right now. I was solving for t, and t ends up being r cosine 20 over 6.84, and you end up solving for r when you find the y direction, which is what I went on and did after that. And you got the equation for it is delta y equals viy times t plus 1/2 the acceleration of y times t squared. And just went in and I plugged in all the variables and numbers that I knew, and did the math for it right there. I could go through all that, but it feels kind of pointless since you can read it. And you end up getting it all the way down there, and you get r equals 3.14 meters. And then you take r and you go back to that last one with t, and you plug in r, and then you solve it out, and you end up getting the time it takes is 0.43 seconds. So by doing all that, you found r and t like I was looking for.